Good morning again, folks. I think we'll get started. Like I said, my name is Jack Rymack. I'm being joined by my associate here, Craig Spears. I will start with just a short PowerPoint presentation. Today's demonstration is on using Softree Optimal with Civil 3D. A couple of slides before we get started with some of the demonstration. You are muted, but if you want to ask questions, there is a question panel available. You can, in the GoToWebinar panel, you can ask your questions, and either I or Craig will answer the questions for you. The video is being recorded, and it will be available on our YouTube page for you to watch whenever you want to. Softree Optimal. What is it? It's a mathematically determines the lowest cost vertical alignment. Gives Civil 3D users the ability to minimize earthwork costs for corridor designs created in Civil 3D. Reduces iteration. Provides quantitative costing data. Helps determine feasibility and budgeting. How does optimization work? Basically, you get some ground. You have to have some ground information. You have to have at least a horizontal alignment. You can also have a vertical alignment. You have to give it some cross-section geometry, pump in some costs, put in some constraints, run it through the optimization technology, and out comes the optimal alignment, as well as the costs of the road and the earthwork movement schedule. Workflow for opportunity. Okay, so Softree Optimal is really well suited for preliminary design. You use your Softree Optimal software to do all of your initial alignments. Send it over to Civil 3D where you can do your detailed work. It's fully compatible with Civil 3D. And then after you've done all your detail work in Civil 3D, you can come back to Softree Optimal as a final design checker. Get your construction quantities and finalize your vertical optimization. Upcoming webinars. July 7th, we have a web demo on, that's a little typo there, on working with coordinate systems and survey data. July 12th, we have using terrain tools for site design. August 9th, we have working with multiple alignments. Sign up for all of those or any of those that you're finding interesting.
Jack, could you just go back to that previous slide? I think there are some mistakes on there. I think we've just done the coordinate systems one.
Sorry about that. The upcoming ones are these two, using terrain tools for site design. Yep. And working with multiple alignments.
I think what's on here is correct. It's just
except that we did this one already.
Inapplicable.
Sorry about that. Okay, let's go on to the demonstration. I will pass it over to Craig. I'm just going to change the presenter.
Okay, I'll just show my screen here. Hopefully you can now see my screen. There's a Civil 3D on it. Good morning, everyone, or good afternoon. It's a pleasure to be doing this. It's been a while since I've done this specific seminar. We've done some similar demos recently, but this seminar, I think, has been a while. So the basic plan is to start with a design that was done in Civil 3D and bring it into Softree Optimal, optimize it, have a look at it there, and then go back and put it back into Civil 3D for drafting and those sort of purposes. Just before I jump in, I just wanted to say a couple of words about why would you want to do this sort of thing anyway? And there's some really good reasons. The first one is that you can use the optimizer to check a design that you've done, and it will give you the lowest cost alignment possible, and in many cases, as you are transportation professionals, you know that there is a lot of money involved with changing alignments. So it's a great way to check what you've done and have a feeling of comfort, knowing that your design is very close to optimality. The other reason to do it is just simply to save engineering time. If you've got a lot of alignment to design, this tool can help you do it very quickly, and so it's a great preliminary design tool. Can save you a lot of time to get to the sort of final stages very quickly by automating a lot of the trial and error. So yeah, I think you know, in general, you would look to using the tool as a starting point, but you can also use it as a checker. I just want to say also a couple of words about the type of project that this is suitable for. And we get this question all the time. Someone gives us an urban design, and it's very constrained. It's got crossing streets, and it's got pipes and all sorts of things that they have to match into. And that is not the best type of project for optimization. The best type of project is an alignment that you can move around or that the optimizer can move around looking for a good solution. So it'll save you all those trial and error iterations of moving around, looking at your quantities, looking at the movement, all that sort of thing. So in general, more rural design, unconstrained, and obviously a design that's got some significant costs, earthwork costs, is a good candidate project for Softree Optimal. So not every project is suitable, but the ones that are, I think you can really save some money and some time using this tool. Okay, enough of the sort of marketing rant. What I've got here is I've got a 10-kilometer road that is rural. I'll show you an image of it in a second, and I've got it here in Civil 3D, and I've got some sample lines set up, and you can see there's a medium in between. It's a highway, and the file that we were given originally came with a profile, and it was designed quite rural. So to get it out of here, what I do, which is very straightforward, is to export these land XML surfaces. So I will just export land XML. By the way, I'm going to export the original ground surface, and I'm going to export the alignment that has been provided in this file. I'm also going to go through a process of trying to get the corridor, the sub-assemblies and assemblies out of Civil 3D and bring them into the Softree Optimal environment. That will save me having to recreate them in Softree Optimal. In many cases, if you're doing a design, a preliminary design, you might want to create the sub-assemblies, templates as we call them, in the Softree Optimal environment, and then when you're finished, you bring the alignment and possibly the subgrade surface back into Civil 3D. I'll explain that a little more in a sec. So I'm going to go ahead. I'm going to export the topo file as well as the centerline alignment. In my case, it's called Rural Highway Example, my original ground surface. So I'm going to export those two as land XML. And I've already done this, so I'll just overwrite the previous version. There it is. And the other thing that I'm going to do is we have a plugin for Civil 3D which will export the corridor. And I'm going to activate that. I'll try and activate that. Oh, there it is. And so what this plugin does is it samples the corridor. It recalculates the corridor, trying to simulate the behavior of the sub-assemblies and assemblies. So I pick an alignment, a sample line set. I have to have a sample line set already created. and I pick a corridor. In this case, I've only got one corridor. And then I give it a limit above and below the existing alignment in which to go. So I'm going to go 5 meters above, 5 meters below, and I'm going to sample every 1 meter. And I'm just going to start this process running. It takes a few minutes, and I'm going to carry on as if it was already completed. So there you can see it's starting to calculate the corridor, recalculating, rebuilding. It's going to go for a few minutes. So I'm going to switch over here, if it lets me, and come on, Mr. Civil 3D, move. It's in deep thought. What can I go? Let me go here. Yeah, let me create a new design. This is something I want to show you later, but let me just go and create a new design. And I'm going to select, first of all, that surface that I just exported, the original ground surface. And I'll press OK to that. So here's my original ground. Loads that up. It finds a tin surface in there. Take the defaults. And this, of course, would preserve any break line information or anything like that that's been created in Civil 3D, so you don't have to do that again. I'm going to just save this in terrain format. And now it's asking me for an initial alignment. I'm going to select Land XML, same file, which I put the alignments into as the original ground. So it loads that up, and I'm going to, in this case, there is only one horizontal alignment and one vertical alignment. Did I lie? Yeah, no, there's only one vertical alignment and one horizontal alignment. So I'm going to use those as my initial alignment and just go ahead with that. And then here I'm going to take this file that I'm in the process of creating over here, and I'm going to bring that in, which is going to give me an approximation of the cross sections very quickly. So just do that, corridor sections, finish, loads everything up, prompts me with some other technoidal stuff, and then loads up our file, and we're here in the Softree Optimal environment, all ready to go. And let's just go somewhere along here where I can see a section, and we'll just have a quick look at what I've actually exported out in terms of the corridor section. The surface is behind the scenes here. It's all been formed up, and as you can see, this alignment matches the alignment that we had in Civil 3D. So we're pretty much ready to go. We've got a cross section. Fairly quickly we have a working model that we can try and optimize. So what the export of the cross sections does is it samples the corridor, the Civil 3D corridor at each of these crosses, and it determines how the corridor model in Civil 3D is behaving at that elevation, and then it uses those sample points to form a Softree Optimal cross section, and in between the sample points it interpolates. So it gives me a pretty good approximation, especially for calculating quantities of what the Civil 3D corridor would be doing. So it's a quick way to get started. Before I do anything, I want to add a couple of things here. First off, I need to set a fill factor, expansion compaction. So I'm going to set that to 0.85. And obviously you can see here you can have multiple materials. You can assign those by station range. You can also assign different stratum layers. Those could come from Civil 3D in the form of a surface, or you could assign them here as a constant depth. So I added an expansion compaction factor, and now I want to, what do I want to do? I want to do some stripping. So I'm going to strip 0.3 meters.
Quick question, Craig.
Quick question, okay.
Is the Civil 3D horizontal spiral data recognized by Optimal?
Yes. Short answer is yes. We do recognize the horizontal spirals. That being said, there may be some exotic spirals that we don't handle, but I think we handle most nuts and bolts spiral curves. Yeah. So what I've done here as I was answering that question is to quickly add some stripping onto my cross section, which didn't come from Civil 3D. And now when you see the cross section, you can see that 0.3 meters of stripping has been applied. So now I'm ready to go. I've got this alignment, and here it is. And by the way, there's a cost with this alignment, and it's showing me that based on some costs, that alignment is about $8 million. And we'll just have a look at those. We're going to unit costs, and we go to the cost tab, and you can see that there is an excavation cost for any materials you have in your design, and an embankment cost. Those are very straightforward. It's just volumes times cost, cut, fill. However, the other cost that's significant is the haulage cost, if there is any, and that is formed by three categories, up to three categories of movement: free haul, overhaul, end haul, and they're defined by a hauling cost and a loading cost. Obviously, the free haul has zero loading cost, so you can set them explicitly here. What we find is a lot of people like to go with a simpler method of entering these, where they can just specify a free haul distance, and it will calculate those costs for them. It's quite flexible, and yeah, if you've got good cost information about your haulage, you can enter it in here. And with this information, you can see over here it's calculating cut cost, fill cost, and a haulage cost, and that yeah. The other thing that affects the cost of the alignment is the source and destination of materials. If you have some pit locations where you have material that's available, you can create a pit here, and that is done at a station. So I've entered a station where I'm going to access the pit, and then I can put a distance on here which would represent a haul distance away from that station access point. Pits can be borrow or waste. They can have infinite capacity, or they could have limited capacity. And what the optimizer will do is it'll figure out the best places to borrow or waste material to according to the pit locations that you've given, and you can put lots of these things in, and it'll figure it all out. This checkbox here indicates that a pit will be used if it's necessary. There may be situations where you have a road intersection or something where you know that you're going to get excess material or need material, and so you would turn this off, and you'd say, at this station, probably take this off, I'm going to need 20,000 cubic meters of material right there, and it will budget for that, and it'll produce a surplus volume at that station. So two types of pits. We call these smart pits because they will only be used if it's economic to use them. If I don't put any pits in, and I just cancel from here, the optimizer is going to try and balance the road. So it'll use its own material to balance everything, which is often the case in resource roads. Well, it depends. What was I going to say? Yes, quality. There is a quality factor, and this applies to filling along the road and also with pit materials. You can tell it that the pit contains certain qualities of material, and then along the alignment you can tell the optimizer that this section of road needs a certain quality or higher. And it will do all those complicated calculations of figuring out where to get material for those different sections of road. So it's quite sophisticated in what it figures out, and it's especially good if you have sublayers like a rock layer or something like that, and it's very expensive. The unit cost for rock might be super expensive, and so you would want the optimizer to avoid those, obviously, and it does, and it tracks all the materials and everything. So let's just go ahead and run an optimization. It can take a few minutes, and I've got some that I've done previous to this demo, which I can call up if this is slow. So let's add an optimization. The first one that I like to do is a user, what's called a user-defined curves. I got to enter some information in here. I've got to limit the range because there is part of the alignment is not included in this. 8718780. There we go. And so what I'm doing now is I'm telling it the range in which I want to optimize. I'm telling it that vertically I can go plus or minus 10 meters above and below. I could reduce that if I wanted. And I'm telling it that I want user-defined curves, which means I want the curve locations to be the same locations as the original design. I like those curves. They're nice. They're aesthetic. They're just where I want them. So I'm going to use those locations and optimize this user's design. I'm going to put in here maximum grade of 5.25 min-max. And this is a fairly high-speed road. We'll go with K values 84 and 86. You can change these things by station range. So we'll just go ahead and do this. And I'm also going to add a control point at the beginning. So quickly add a control point at the start. And I might want to put a grade control on at that point too. Looking at the time here, I'm probably running a bit behind time. Yeah, so just to summarize, I've told it that I can go plus or minus 10 meters over this range of stations. I'm going to stick with the user curve alignment that I was given. And then I'm going to add some control points to make sure it goes through those points. And these control points can be anywhere along the alignment. They can be at intersections, pipe crossings, anywhere where you want to fix the alignment. And it's important to know that the more you constrain it, I mentioned at the beginning, urban design is not so good for this tool. And that's because the more you can constrain it, the less chance it has to move around. And you will eventually possibly over-constrain it or make it infeasible. So I generally recommend starting with something that's not constrained and progressively constrain it the way you want if that's what you want to do. And at some point, stop optimizing it and take it back and maybe finish it manually rather than trying to force the optimizer to do all the things you want it to do. So there's a happy balance. Anyway, the more constraints you have, the less opportunity the optimizer has to give you a better solution. So there's my new alignment. I'll just call it user curves. And if this doesn't solve quickly, I will switch to the one I've already solved so we don't sit here looking at my screen. User curves, we're ready to go. Let's process this alignment and compare it to the original. So it starts out by doing some cross-sectional calculations. This is quite predictable how long this will take. And then it will get into the optimization, the hardcore optimization, which can take a lot of time. While we're sitting waiting, is there any questions? I'm going pretty quickly here. No? Okay, well, I'll just ramble on. So the optimizer was developed by Softree along with UBC. We've been working with UBC for about 5 years. We're also working on horizontal alignment optimization. So hopefully this year you'll start to see some of that. One of the key features of our optimization is that it's accurate. Other attempts, previous attempts at optimization have they haven't represented a detailed cross section, and they've also been heuristic in their solution. So the solution that they come up with is not necessarily the best solution. So those are the key things. And we patented last year we patented this technology. We do have a patent for it. So it's we're quite excited about it. We're going through the process of making it more friendly, easier to use, that sort of stuff. So this tool can be quickly applied in the design cycle. Looks like this is taking a couple of minutes. So I'm going to switch back over to some ones that I've already done just prior to this. And we can have a look at the results of those. So that was the original, there was the original cost. And here if I switch to fast curves, I didn't show you fast curves. It's a very curvy road. I've actually reduced the cost hugely. But the result, I don't think most civil engineers would like the result. It's a bit of a roller coaster ride. But this one, which I started a second ago, which matches the user curve locations, you can see that this one, which is selected here, and this one, match user, that I brought the total cost down by about 15%. And that's with the same curve locations. And I can set this current. We can have a quick look at it. Oops, set current. There it is there. There's the profile. And it's pretty much balanced. There's some sort of edge. It's very close to being balanced. It's a 10-kilometer road. And the cost is significantly less than what it was, 13% less, and we've just simply optimized it. So there's a case where I've done a design. I want to see, could it have been a little bit better, and I don't want to spend days moving the alignment around looking at it. I've got a very quick answer and something to compare to. Now, there's other types of curves. I'll go back here to this curve panel. We had user-defined, which we started. We had fast curves, which is very curvy and very low cost, but very curvy. It's going to try to follow the ground. Some of the other options here, variable curves and tangents, which produces quite a good result, but it takes a while to process. And here we have it, the results of that here. And now we're getting, and this is real data. We are getting a 30% improvement in the cost. Significant. And again, it gives you a baseline to compare to your original. It's a great way to do a sanity check on something you've designed. Is this as good as it can be? Yeah, I'm going very, very, very fast here. So I could have created any one of these situations. I did not need the original vertical alignment to do this optimization. I could have come in and just put in a horizontal alignment and optimized it to get a vertical. So it's very quick for that. And I have another example here. Oh, this is now found a solution, and it's telling me that it's still looking for improvement, but in the best case, we would only get about 1% improvement. if I let it carry on for a while. That's called the optimality gap. I think I could just safely cancel this, and it will complete its calculations, and we'll get, we will see that the run that I started will produce the same results I just showed you in a minute. And it's taking a second here to do the post calculation. So let me switch back here to other example. Oh, there. Too many screens going here. Which is it's not that one. No, I closed it. So it is this one here. And I'll close this. Sorry, I lost my file here. Here it is here. I've now got 3 instances of Softree Optimal running and Civil 3D, just to confuse you. Okay, so what I wanted to show you was that I've done an optimization of this original alignment, and now I want to look at another alignment and see what the difference is if I create another alignment. So I'm going to go in here and I'm going to copy that alignment to make a new alignment, horizontal alignment 2. And there it is. And now I'm going to move this, just straighten it out a bit maybe. Move that over. Okay, so there is a message saying that the vertical curves that I had won't fit in the tangents. So it's going to remove them. But that's okay because we're going to now optimize this newly positioned horizontal alignment. So again, I would just go up here to options, options, make sure that everything's set. I'll do a fast curves so I can do it while you watch. Fast curves. And I'll process that new alignment, and then I can compare the cost with the other horizontal alignment. So the whole point here of this conversation is that you can try different horizontal alignments quite quickly, optimize the profile, and compare. It's a very fast process, so you can get a lot of iterations in quickly. The other thing that you can do is to change those K values, change the design speeds, and rerun this, and very quickly compare costs. So it gives you a lot of ways to play around with it. And I'm going to switch screens again rather than wait for this. Go back to this one, the original. Okay, so now let's suppose I want to go back to Civil 3D. It's pretty straightforward. I don't need to send the surface back. I could if I wanted, but I can save the alignment, save as land XML, call this optimal alignment, call it optimal alignment 1. It's an XML file. And I'll disable some of the things that I don't need. I could export the subgrade surface along with the alignment. So when I get back to Civil 3D, I can just call up some sample lines with that subgrade surface, this surface here, at the optimal location, all ready to go in Civil 3D. So I'll just export that, go over to Civil 3D, which is here. And by the way, the export that we did here finished and created that CSX file. So to bring the alignment back in, I go to Home, Insert, Land XML, and I can bring in that optimal alignment, and it brings in, it'll bring in a new horizontal as well as vertical alignment here into Civil 3D. And then I think you can, I'm not a super user of Civil 3D, but I think you just retarget the corridor with that new alignment and away you go. So yeah, that's it. This is the one we created here, the new one. And I think I can just retarget the corridor. So just to re-summarize, we started in Civil 3D with a design file, something that was supposedly completed. We brought it over to Softree Optimal. We set it up there. We approximated the cross sections. We did that pretty quickly. We then tried a few different optimizations of that to compare costs with the original. And then we exported it back and brought it into the Civil 3D drawing. So that's the process. And obviously, when you go to do real examples, there's more to it than that, as always. But you know, that's an outline of the workflow. So that ends my presentation.